Good morning, fifth graders. This is Ms. Jagodnik here, and I am here today with the last lesson in chapter 17, lesson 1710, which brings us back to geometry and talks about area. So if you recall, area is the surface of a shape. We usually find area, we're talking about rectangles or possibly squares. And we find area by multiplying. It's like having an array that just doesn't have the boxes filled in. You're multiplying the number of rows times the number of square units in each row. So really remember, area is length times width. Nice and easy. But today's lesson extends the idea of finding area to other shapes. Now that we've talked about other kinds of quadrilaterals like parallelograms and rhombuses, we want to be able to easily find a formula to use for the area of those too. So if you looked at the slide before, you'll notice that the way to find the area of a parallelogram is kind of to envision it as a rectangle. So if we look up here at the parallelogram, if you can envision this like, hey, I know how to find the area of a rectangle, and this kind of has a rectangle inside of it. But it also has these two triangles on the edge, one of them this way and one of them this way. But if I look at those triangles carefully, I see that they're equal. They're what we call congruent. They're the same size and shape. They're simply flipped upside down facing the other direction. So if I can envision taking this triangle and putting it over here, it would fill in that space and it would bring me back to a rectangle. So this is where our formula for area and parallelogram comes from. It's very similar to finding the area of a rectangle. Instead of calling it length times width, we're going to call it base times height. Base is this, the entire bottom. Because you can see even when I move around the triangles, that is side to side how big this shape is going to be. And then height is this side right here, the vertical. So the only tricky part of this is remembering I'm not measuring that diagonal, because when I turn it into a rectangle, that's not where it's going to be. I want to measure this vertical side, so top to bottom. So on page 923, we're going to go through the guided practice and practice using this formula. So your multiplication skills are going to have to be good. We got some decimals, we got some two-digit numbers. We're going to have to work on that. But other than that, the formula is real easy to use. We're talking about a very similar formula. We get the numbers, we multiply, and that's our answer. Okay, so number one says that the base of a parallelogram is 8 meters and the height is twice the base. So here's one thing I need if I'm going to do base times height. My base is 8. And the height is twice the base. I know that twice means 2 times. And the base is 8. So 2 times 8 is 16. The height of this parallelogram is 16. So to find the area, I'm going to have to do 16 times 8. So let me set that up over here so I can do my algorithm. 8 times 6 is 48 and carry the 4. 8 plus 4 is 12. So I have an answer of 128. Okay, what unit do I want to use? Remember, if you're doing area, you're always using square units. So I see they've given me the base is meters. So that means this is in square meters. 128 square meters is the area of that parallelogram. Okay, question 2, just a thinking question. Can you use the formula for area of a parallelogram, this one right here, base times height, to find the area of a square? Okay, I can think about that in a couple of ways. One, I can envision a square. This would be the base and this would be the height. Okay. Is that how I would find the area of the square? Yes, it's just another way of saying length times width. Okay, so yes. The other way I could answer this is by using my knowledge of geometry. Remember, a square, pretty much everything. Okay? A square is a rhombus, is a parallelogram, is a rectangle, is a quadrilateral, is all those other things. So if this is the formula for a parallelogram, then it should work for a square because a square is a kind of parallelogram. So that's the other way I could think about that. Either way, the answer is yes. Okay, now we're going to get into some actual here's some calculations to do. So, number 3, here's my parallelogram. As promised, we've got a decimal. Because, you know, that was a 5th grade skill. You've got to be able to still use it. So I have my height right here is 21.5 inches. And I have my base is 20 inches. So I have both pieces of information I need to calculate area. I just need to multiply. So 21.5 I'm going to put on top. It's the longer one that's easier. And I'm going to do times 20. Okay. So I'm going to use my easy little shortcut strategy. I'm going to take that 0 off for now. And we'll annex it again later. Because we know we can do that. So just 21.5 times 2 here. So I got 2 times 5 is 10. Okay. 2 times 1 is 2. Plus 1 is 3. And 2 times 2 is 4. Okay. And then we can put that 0 right back over here. So I end up with 4,300. Now we've got to place the decimal point. We know we always check how many places are behind the decimal point. There is 1 place behind the decimal point. So I'm going to put it there, and that 0 is behind the decimal point. Now we know that when all we have behind the decimal point is a 0, it's not necessary. We can take it right off. So I end up with an answer of 430. Unit is inches. So then area would be square inches. All right, not too bad. Okay, going to rhombus. Okay. Remember that a rhombus is a parallelogram. It just has all equal sides. So the fact that they're throwing in the word rhombus doesn't change anything we're doing here. I have a rhombus where each side is 15 meters. So what they're really saying is these are all 15, each one of them. So if I want to call this one my base, I know it's 15. So they're not calling it base, but they're telling you all sides are 15. So one of them I can call the base and make it 15. The height here is 12. So what I need to do is 12 times 15. Okay, so 15 times 12. Here's my 2-digit times 2-digit. 2 times 5 is 10. Carry the 1, that's 3. Now I'm working with the tens place, so I put that 0 down there first, and then the 5, and then the 1. 0, 8, 1. So my answer should be 180, and my unit, again, is meters. So my area I give in square units, square meters. Remember, if you're getting confused with multiplication or you know it's something you make mistakes on, you can always estimate to check your answers and make sure that they're reasonable before moving on. So, for example, this one is about 20 times 20. So that would be about 400. So this is reasonable. If I made a mistake with the decimal point and I ended up in the thousands or I ended up with 43, that estimation would keep me from leaving that mistake there. I would know I'd have to go check. Same thing over here. This is about 10 times 15, which is about 150. Oh, good, this is close. So I must be in the right area for my answer. Number 5, okay, quick and easy. They just gave me my 2 measurements. All I have to do is multiply. So again, with the same algorithm, I'm going to put the big one on top just because I find that easier. It doesn't matter for your answer. There's 12, carry the 1 is 9. Put down the 0 before I multiply the tens. There's 3. There's 1 times 2 is 2. Add them together. There's a 2. 12, carry the 1. 322. So is that right? About 20 times about 15. So that would be 2 times 15 is 30. So that should be about 300. Oh, good. I see my unit is centimeters. So I'm going to make the area square centimeters. Okay, last one in the guided practice is another parallelogram with 27 feet as my base and 32 feet as my height. So I'm going to set up my 2 by 2 multiplication again. 7 times 2 is 14. 7 times 3 is 21 plus 1 is 22. Put down my 0. 2 times 2 is 4. 2 times 3 is 6. Add it all together. And I have 864. So about 30 times 30 is about 900. Oh, good. That's nice and reasonable. And my unit are in feet, so this would be square feet for my area. Okay, so we now have all of the guided practice done. You notice I put a couple of extras on the bottom, even though they're part of the independent practice, because as I was going through and doing these problems, I noticed they're trying to trick us, as they usually do on one or two of these. So I want to make sure you're not falling for this trick, and this is something you remind yourself to look for, because it changes how you do the problem, adds an extra step for you. If I take a look at number 10, 10 is a rhombus and each side is 4 centimeters, but the height is 60 millimeters. So before we go multiplying 60 times 4, let me repeat that a little more carefully. Each side is 4 centimeters and the height is 60 millimeters. So remember, one thing that you are responsible for knowing at this point is how to convert different units. So if I have two things in two different units, I cannot find the area until I change them over to be the same unit. Now I could do it either way. I could change the millimeters to centimeters or the centimeters to millimeters, whichever one I'm more comfortable with. But one of them has to be changed. So if we take a minute and think back, or you can flip to one of your conversion charts if you need that kind of help, that's fine. Centimeters, I know it takes 100 centimeters, that's what the cent means, to make a meter. And I know it takes 1,000 millimeters, because that milli means 1,000, to make a meter. Okay. So if this is 100 times, and this is 1,000 times, that's a difference of times 10. Okay. Millimeters are the smaller units, okay, and therefore there's more of them. So if I want to change my centimeters to millimeters, I have to do times 10, because if I started at meters, I've already done times 10, 100 to get to centimeters. I need to do another times 10 to get to millimeters. So I can either do centimeters times 10, or I could take my millimeters and go the other way and divide by 10. Okay. Because I see a 0 here, I think I'm going to do that. I think I'm going to divide this by 10. Because now I just end up with 4 centimeters times 6 centimeters, which gives me 24 square centimeters as my answer. That was nice, easy multiplication. But if I decided to go the other way, I could do that too. If I want to do it in millimeters, I'd have to multiply this one times 10. That means I'd be doing 40 millimeters times 60 millimeters, which is 6 times 4 is 24. And then annex the two zeros, 2,400 square millimeters. So that makes sense, because millimeters are 10 times centimeters. And if I do 10 times for the base and 10 times for the height, then altogether when I get the area, it will be 100 times as great. And that is what happened here. All right, parallelogram, again, I see they're being sneaky with the units. The base of my parallelogram for number 12 is 16 inches, and the height is 2 yards. Okay, so those have to be changed over. Okay. So in this case, I have to remember 12 inches equals 1 foot. Again, if you have a conversion chart, that's fine. And 3 feet equals 1 yard. So if I start dividing the yards up, I'm going to end up with decimals or fractions. I don't think I want that. So I think in this case, what will be easier is to turn everything into inches. Okay. So 2 yards, okay, times 3 feet. If 1 yard is 3 feet, 2 yards will be 6 feet. Okay. Now I have 6 feet, and that's times 12 inches each. So that's 72 inches. Okay. So my 2 yards are 72 inches. Now I can do 72 times 16. See, I could have done the other way, but inches, I would have had to divide to find out how many yards 16 inches are, because it's less than 1 yard, and that would just be a mess. So I'd rather do my multiplication with my whole numbers. 72 inches is my height, 16 inches is my base. 6 times 2 is 12. 6 times 7 is 42, plus 1 is 43. Now I'm working with tens, so put down my 0, 2, and 7, and then add together. 2, 5, 11. And my unit, since I changed everything over into inches, would be square inches. Let's just make sure, because I did all that converting, that it makes sense. This is about 70 times about somewhere between 10 and 20. So 70 times 10 would be 700. 70 times 20 would be 1,400. So my answer should be somewhere in between those. Oh, and it is. So that looks like it's reasonable. Okay, so there's a quick lesson in how to find the area of a parallelogram, or of course a rhombus, because that's just a special type of parallelogram. You figure out the base and the height and make sure you give your answer in square units. Also make sure that you check that the units are the same. You might have to change over one of the units before you can start multiplying. Okay, on your own, you can finish the rest of page 923 and go on to 924. Any questions or anything you want to go over, make sure you bring it up to your teacher when you meet with her live. Next time I see you, we will be doing some review lessons on important things we've learned in 5th grade. This was our last lesson in the book, so nicely done getting through this step up to 6th grade chapter. And after this, we'll be reviewing and making sure everything is fresh in your mind at the end of the year. So I will see you in a couple of days.